Okay, right. So we're on YouTube. A little piece of admin. So tomorrow we have our first tutorial. You don't have to start anything. You don't have to learn anything for tomorrow, but we will get a tiny little test of some kind. Okay. The labs we are going to use are too small to cater for all of you. They'll cater for all of you, but not this class and the other class. So we'll have to divide the whole class into 2 groups, and you'll have 1.5 hours in one group and 1.5 hours in the other group. If you're in group 1, you come at 2 to Narga A and B. If you're in group 2, you come at 3:30 to Narga A and B. Now, I do not want to confuse you. Once you get to Narga A and B, I'll split you up into A and B as well. Just like in this class, you can choose to go to either A or to either this room or the other room. You can choose to go to either A or B, but they're also 2 separate rooms. If you have an issue, have a legitimate issue about not being able, I shouldn't look this way, not being able, otherwise YouTube can't hear me. If you can't come to either the early session, but you're in group 1, or you can't come to the late session, but you are in group 2, please send me an email directly and just tell me what your conflict is. If it is, I have to go home and care for my cat, that's not legitimate. If it's, I'm also writing actuarial science test at exactly the same time, that's kind of more legitimate. But there shouldn't be those kinds of conflicts. I mean, it's only a few students who take this subject and something else that has a conflict. If you're in a conflict situation, I'll keep you in either your late group or the early group, depending on when you have the conflict. But for the rest of us, I'll swap us around each week. So if you come early this week, next week you'll come late, just to make things fair. Where do you have to go to? You have to go to Narga A or B. Who knows where that is? I can do anything of this class by just asking a question, and it's always a subset of people who should be answering the answer. Okay, you don't know what it is. I'll tell you. I'll tell you. And I don't mind. And even if you do know what it is, it's a good idea to know again. I don't know where it is, but let's see if we can find it. Let's go Ingorishu. And odd little search bar. Fine. Main compass map revised. Oh, what's happened? Ooh, okay. Oh, I'm too lazy. That's fine. So we'll just have to not use the exact right orientation. But we are here in 51. That's engineering building. I guess it's north is kind of this way. So north is to the left. So if you ignore that aspect, if you can't read maps in any case, this whole thing is wasted on you. We're in the engineering building. There's the one that says number 1 over here. Sorry, number 4, right over there. This is the GThe library. This is that red plane. There's that gardening stuff right above the library. There's the NLC, and here is admin A. So to get to Narga A or B, you go, let's see, you walk, better to walk across the bridge because it's safer. So you're walking across a dangerous road, other side of the bridge, then you just walk down all the way, this parking lot and trees, and you go right in at the side of this building number 22. And it's on the first, on the second floor. Second floor, first floor. Right. We'll meet there. Don't come here. Which group are you in? Let's just log in here. That's probably going to ask me for my login credentials. Log in. I'm logging in. You've all logged into Sunrise, haven't you? Well, I can check this login in advance. So I'll check out if they got some logs. Okay, these are all the courses I'm taking this year. I've put up a notice because someone asked me if you go to 113, then there should be a little notice that says 113 and 114 are really the same course this year. In the future, when I split up, and for this year, it's really identical. Actuarial student, you should take one. You must take 113. If you're not an actuarial science student, you must take 114. Unless you have some kind of funny connection. Don't know. Maybe your uncle is the president of South Africa and he arranged for you to do 113. I don't know. I don't care. There we go, 114. This is our beautiful website. I think Sunderland looks pretty ugly, but it's okay, it works. Here are the lecture slides. I tried to put them up right after the class, which means within 1 or 2 weeks. Here are the YouTube videos, but we still might record it on Monday. So I've asked people to have that fixed, but it's not clear if or when that'll happen. And tutorial groups. You log in, go to this page for OPT. So you go to tutorial groups on the Sunday. Right. Everybody happy? Any questions you want to ask me? Where are the people I know? Where's Robin? Somebody learned your name. No, you're not Robin. Don't lie. It's not right. Miss Robin, you don't know. Who else do I know? What's that? What's that name? Shaw. No, it's not like an Irish name. Was it Shaw? Yes, you are Shaw. Hey. And Jason? Oh, there must be friends sitting next to each other from bullets that happen in Islam. What's your name? Garrett, yes.
Well, what is the shape going to be about?
What is that?
The shape.
Oh, nothing. I don't want you to panic, I don't want you to study, but we've only done problem solving. This is about problem solving.
Yes, but I still don't know how we're going to use induction for problem solving.
Well, we'll practice that on Thursday. Okay. All these things I think you need to practice. So, there's no magic way that I can tell you or show you induction, and you will suddenly just be able to solve all induction problems. It's almost always a struggle. Last Monday, which is day before yesterday, I taught my honors class, and we had a problem that we knew we could solve with induction. I know because I made the problem and I solved it. I didn't make any effort, so I didn't even prepare for that class. It's a general discussion class at evening. And so when it came to the class, I completely forgotten how to use induction to solve the problem. And sometimes what you have to do is stand there and go, shall I try this, shall I try that? What do I do induction over? So that's let's like don't be good night. Oh no. I don't even write the tutorials until an hour before they happen. I don't want to commit myself to make it more relevant. No, we don't give out tutorials in computer science. I mean, I think most subjects you won't get the tutorial until you come to class. There are many reasons for that. We want students to struggle. We want them to sit there and struggle and be helped by systems. Because that's somehow how you learn. If we give out the tutorials beforehand, people will somehow prepare for them and do them at home, and then they won't do the actual work of coming to class and interacting. We think you learn a lot more when you interact like that. Okay, so don't expect to see probably any tutorials. Who knows? Maybe someone else will come along and teach the course in a different way. Right, so that's administration. Now we have to talk about our third technique for solving problems. So Gareth has already admitted that he didn't follow the induction at all, which probably translates to I didn't explain it very well. And I can appreciate that. What did I shoot for? Somebody's supposed to somewhere. But it is a difficult concept, and you only get it right if you practice. For now, it's enough for me that you just know about it. We also talk about invariants, which are even trickier than induction. You should kind of be familiar with induction from high school, or Gareth, do you have AP Maths? Or what's it called? Advanced? You're taking it now, but at school, did you do advanced stuff?
We didn't actually 114, but we used it to solve a proof. We didn't use it to.
Damn it, you've caught me. So when you solve a problem, you are proving something. Well, apart from the fact that you prove it, you can solve it. All uses of induction, in fact, all solutions to problems are proofs of some kind. So the mathematical induction that you heard about in 114 is exactly the same thing as the induction you do in this group. It's always 3 steps. Prove the base case, so prove it for n equals 1 or n equals 0, maybe n equals 2. Assume that it holds for n, and then prove it for n plus 1. That's what you did in maths, isn't it, Gareth? Do you remember it? When did you do this? In the last few days. It's been very recent because that term hasn't been very long. Okay, fine. But that's exactly the same thing. I'm glad they also do it. You use it in almost all mathematical subjects. I'm not sure if you use it in mathematics. Use economics. Usually economics. Let's pick a big term. Yes. No, you're not ready. Oh, good. Okay, what's your name? What else? Johan, do you prove anything in economics? That's what economics does. I mean, prove that. Find that. Do you know anything about economics? Not yet. Well, there's only one thing. The whole of economics is just one sentence. Supply follows demand. That's all it is to it. I've just given you all your economics in 3 words. We know induction, invariance. Well, we think about it, but I just showed you a brief example. We'll practice that as well. But here is the third technique. It's an old puzzle. You must have seen these kinds of puzzles before, unless you're a kind of new generation student and you haven't really come across puzzles. Which I understand, because there's so much on YouTube. There are cats and snails, and I don't know all this stuff. So maybe you haven't seen lots of puzzles. But this is kind of the classic. You see a lot of this. Let's just see. A farmer wishes to ferry a goat, a cabbage, and a wolf across the river. Damn, I found a picture of a really funny looking goat that I wanted to add to this slide. Obviously, Okay. Goat, cabbage, and wolf. However, his boat is only large enough to take one of them at a time. Take himself and the wolf, or himself and the cabbage, or the goat across. Okay, so that's like several trips, ferry them one by one. But there's an issue. He can't leave the goat alone with the cabbage, because the goat will eat the cabbage. And he can't alone with the wolf either. The wolf will eat. So at all times, the wolf, the goat, must either be on his own or the farmer must be present. Yes, what's your name? Pencil. Pencil. Okay. What's on YouTube?
The video on.
What's in the video? What's just the picture? I'll make a video of the goat. Yes. Is it on the now? It's now, but it's 10 minutes delayed. You only hear my voice now. You only hear my voice now. Someone else wants to ask a question. But the other videos, let's just check. This is kind of important to me because even though I don't have many subscribers, I've got like 10 subscribers for the last 5 years. I think it's useful, and when I'm lonely, I kind of play my videos and listen to my soothing voice. Drift off to sleep. Gentle tones. Sitting at computer side. Come on, YouTube. I hope YouTube is not going to crash if I play it inside itself. Okay, you can't hear the sound, but it's on there. That's me. Not yet. It's not finished yet. It's not over yet. But it will be when it's done. And at the moment, I'm streaming it. So if you're at home, you get a 10-minute delay. You'll get my voice a little later. You'll get my voice a little later. Now it was on a loop. Let's get back to the farmer. So he's got captain about the wolf. He has to train him across. Don't be shy. Try to no answers. Okay. Can this be done, and how does this farmer do this? So, will induction work? Well, induction is a little tricky, because what are we going to induct over? I mean, there's always something that goes up and up and up and up. The whole ideal induction is that it's like a ladder. You only have to prove the bottom step. If you can prove that the ladder has a bottom step, and that if it has one step, it has also the next step. If you can prove that, you know that you've got an infinitely long ladder. It goes up through all ends. So the number of lines, you don't have to worry about the number of lines because we just proved it for reduced induction. Then it was the theorem about covering regions was valid for all ends, or 1,000 handle. We can solve it for any number of disks because any n disks because we used induction. But here, there's something that's really grown. It's not as if the farmer is going to take one wolf and then 2 wolves and then 3 wolves, 4 wolves, a load of cabbages or many goats. This one is kind of fixed. Now, maybe we can try, if we're really stuck, to generalize the problem and to say that there is any farmer and they've got K goats and M cabbages and L wolves that they need to ferry across D rivers, that they have A boats that they can use, and all kinds of generalizations. But let's not resort to that extreme yet. Can we use some kind of invariant? So now we're getting a little closer to something that we can think about. Maybe I can describe this problem mathematically. Remember with the chocolate that we had to cut, we kind of made a mathematical description of the problem. We had P, the number of pieces, and C, the number of cuts that I've made. And then I could kind of write an invariant for those two. Or when I had the tumblers, I had U, which was the number of tumblers that are upside down. And from that I could somehow make up an invariant. So maybe I can somehow say that as a mathematical description for this problem. And in fact, that is going to be my first step. But after you play around with invariants, you'll find it's really difficult to say anything that's true. And the only thing you can really say that's true is that the goat in the cabbage will never be alone, and the goat in the wolf will never be alone. But apart from that, there is no real invariant. Not something that we can discover that can help us. So we can try for a while, but you'll find that invariants also don't work. And at this point, you're kind of stuck, because we haven't done the technique we're going to do today. But after today, you'll know this third technique that you can apply to problems. So when you get a problem, you go through that list. Do I understand it? Do I think it's even possible? Is there too much information in this puzzle? Do I have enough information? All those kind of questions. And you say, okay, how am I going to solve them? What techniques do I have? Induction, invariance, and today also decomposition. So we start with a mathematical formulation. So what I'm going to do is I'm going to give names to the elements. This is going to be a mathematical description of the problem, but it's not going to be numerical. Just using things I know from mathematics, little symbols, to make it a little easier to write down. So I'm going to write down F for a farmer, or the farmer, A for the goat, and B will be cabbage or wolf. B can be either one. And then I'm going to write down the current state. I go to the river, I take a photo, a snapshot, and I record what I see on the photo. And what I see is there's something on the left bank of the river. Don't know what it is. There's something on the river in the boat, busy crossing the river, and there's something on the right bank. And this can be things like, on the left bank there's a farmer, a goat, and two bees. Cabbage or wolf doesn't really matter. And inside, on the river there's nothing, and then on the right bank there's nothing again. So this is the very start state. This is how I came across the puzzle in the first place. The farmer, the goat, wolf, and the cabbage, they're all on one side of the river and they want to cross. They want to end up on the other side of the river. So all three want to end up in this state. Nothing on the left bank, nothing on the river, and farmer, goat, cabbage, and wolf on the right-hand bank, on the right bank. What I have to do is to find out how can I make the farmer, cabbage, FABD go from left bank to right bank. So I'm not really using any mathematics. I'm not multiplying anything or adding things together. We're using differentiation, or integration, or calculus of any kind, geometry, any kind of stuff. I'm just writing it more deeply. What is your name? I'll learn all your names eventually before I go. What? Ali what? I'm sorry, I'm a little deaf, but it's just a difficult name. It's not a, it's probably even a South African name, it's from Zimbabwe. It's from Singapore. It's not a Zulu name, it's probably Xhosa. What does it mean? That's not, that's more, no. That's Bali. Okay, I'll have to trust you because my Xhosa isn't very good. Now, that's a good question. Any interaction? Yes. You're right. We definitely do not interact. But more importantly, they are really the same thing, in the sense that they can't be left alone with the goat. If you just think about things that you can't leave alone with the goat, cabbage and wolf are the first things that come to mind. And they're the same in that respect. Now, as it happens, there's no interaction between the cabbage and the wolf, so I'm kind of safe on that ground as well. The cabbage won't attack the wolf will eat the cabbage. But it could have been things that might have been active. Like it could have been a wolf and a mouse. No, not a wolf and a mouse. A wolf and a wolf and delicious chocolate souffle. As we well know, both wolves and goats eat chocolate souffle. Voraciously. So, in that case, the wolf and the chocolate souffle would have interacted in some way. But maybe I could have anticipated in which case it wouldn't matter. I'm not sure if that confuses you or clears up your problem, but it's fine to ask questions. Right. Now, let's just recap. We have a slightly mathematical description of our problem. We know where we start, we know where we want to end. Now I have to describe how do I go from one state to another. And that is by performing an action. And action is just another of these little descriptions. But now there's something on the river. So whenever there's something on the river, I'm going to call it an action. Like that very first one. 2B, so the wolf and the cage are on the left bank, but the farmer and the goat, S and A, are in a boat on the river. And they're heading, I guess, towards the right bank. I can't really tell from this little action if we're going to the right bank or if they're actually coming back from the right bank and going to the left bank. But that's fine, it won't confuse me in this problem. It won't confuse me because I'm going to write those actions between two states. If P is a state and Q is a state, so P and Q are two states, let's say a starting state and an ending state, I'm going to write it like this. Curly braces P on the left, and then some action or sequence of actions, maybe many actions, and then a final state in curly braces again. Like so. And here's a little example. This is my starting state. Here is the action I had above where the farmer is taking the goat across, and then my Q state, my right state will be, okay, once the farmer has carried the goat across, there's a cabbage and a wolf on the left bank, and a farmer and a goat on the right bank. This is easy peasy stuff. You agree? Who do I know that I can ask? Robin? Dwayne? Garrett? Gwen? It's an Irish name. You can't be Garrett. There's another Garrett. What's your name? Aiden. It's like you're a boy band. I should remember that's easy. Yes. Every boy band has something. Every Irish boy band has one rule called Aiden. That's just the rule. Jason, okay. You understand what I'm saying? Okay, Garrett. It's okay. What's the little guy here? What happened to him? Must be good. I kind of figured out the contact with your band?
Yeah, something like
right. I mean, one guy, that's even your real name. Not a photo name. I've never ever heard of it. Right? Common. It's quite common. In your family, maybe, but it's like why do you know people of that name? I've never ever heard of it. I've had many student names. Well, not that many. In any case, right. So everybody's happy. I've got states, I've got actions describing how I get from one state to the other state. And I know what my initial state is. It's this one on the left here, which is the same as this one here. And I know what my final state is. I all need to be on the right bank. So all I need to do is to find the sequence of actions that will get me from the first state to the last state. Now, we haven't talked about decomposition at all. This is all just little mathematical voodoo to make things easier to manipulate. I'm just writing all of this so I don't want to write on a piece of paper, farmer takes the goat in the boat across to the right bank. It's just going to be tedious. And if I start making little ad hoc drawings, that's not going to work either. So what I'm looking for is a sequence of actions, which are called S0, one or more actions, that will take me from the left state to the right state. And here is where decomposition comes in. I'm going to try to break this problem up into sub-goals. Getting all of them across is too difficult. So I'm going to try and see if I can just get one of them across. If I can just get from this initial state, where they're all on the left bank, to a state where only the goat is on the far bank, on the right bank, then I'd be really happy. And if I can do it forward, I can just reverse my actions. So working back from where I want to end, if I can do this S1, I can also do this S3, which takes the goat to the left bank. So I'm using symmetry. I'm using the fact that my solution is kind of reflective. If I can get to this right state in the first line after S1, I know that I can also get to this state from this final state I want to be in. And then all I need in the middle is a way to get from this state to this state at the bottom. So I'm breaking my problem up into other problems. I don't know the solutions yet, but I think that they might be easier to solve. I think those S1, S2, S3 will be easier than solving the whole of S0 in my head from scratch. And now, I mean, one of the important things about decomposition, breaking a problem up into smaller problems, is that when I'm solving the very first one, when I'm looking for S1, I don't have to worry about the fact that later on I'll need S2 and S3. I can forget about S2 and S3. All I need to focus on is solving S1. Just getting the goat across. So, you won't get any marks for solving S1. It's so simple. We're all in the left bank. The farmer gets in the goat. Sorry, the farmer does not get in the goat. Gets in the boat. He takes the goat across to the far side, and then he gets back in the boat and goes back, right? So S1 is this step first, and then I do this action, and then I end in the state where the goat is on the far side. Yes, nice. What? Luca. You said Luca. Luca. Okay. One thing is over, yes.
Why, if they can't be in the road together, can they be on the same level together?
When the farmer is around, you can taste the goat. Once you start eating the carrot. So you can taste it. Say again? Oh, but let's see the farmers going across. Okay? We can play act this. All the manuals say that you should play act these, whatever your subject matter is in class, because that will teach people to learn better. Do you want to play act? Yes. Anybody wants to be the farmer and the goat? The carrot? What? I just get it. This will create chaos. So here's the farmer, he gets in the goat, he gets in the boat with the goat, right? And he goes across. And on the left bank we have left the cabbage and the wolf. But that's fine. I can leave the cabbage and the wolf alone, because wolves don't eat cabbages and cabbages don't eat wolves. That's fine. The only rules are the goat and the cabbage should not be alone, because the goat will eat the cabbage. And the wolf and the goat should not be alone, because the wolf will eat the goat. You understand? You got what do you? Yeah. Okay, good. It's important for me that you understand. As I tell students every year, I don't really care about the score. There are some outcomes in written exam and all that stuff, but it doesn't matter if you only cover half the material. As long as you learn something from the book, that's important. Much better if you learn something well than cover all the material and you don't really learn anything. Who's that calling? Pencil? I can hear your phone. I know your ringtone. And I know your ringtones. I can spot them in the ground. Right. Okay. Now, since I've solved S1, and I've already told you that S3 is really the same, it's just a mirror image. We don't even have to solve S3, we can just write it down. In S3, things are just mirror reversed. So if I end up there, the previous step must be that the farmer brought the goat back from the left bank. So that and that are just mirror images. And this situation and this situation, they're just mirror images. And the previous step must be that the farmer comes back for the goat. So just to play this forward, there's a goat on the one bank, the farmer, wolf, and carriage is on the other side. The farmer comes back for the goat. Look, he's getting in the little boat. He's coming back for the goat. Now he's with the goat. And then finally, he takes the goat across, and they're all on the far side. Right. So in this first S1, the farmer goes and delivers the goat to the other side, comes back. And here at the end, he fetches the goat back from the red bank. Anyone ask anything? What's your name? Your hair is very white. Is it natural? You're going to play along. If you're blind, you can say this. Anybody else is unnatural here? Not really. But it's very distinctive. I like it. Right here. Right. Now we're stuck. We kind of left the difficult problem for last. Because now we have to solve the tricky part. How do I get, I've got a farmer who goes to the cabbage. I need to take the farmer that goes to the cabbage to the other side where there's a goat, and I need to bring the goat back. And I cannot leave the goat and the cabbage or the goat and the wolf alone on the same bank. So how do I do S2? Well, the solution that's on the slides is kind of okay, I guess. What they say is that at the end of S1, let's just see, at the end of S1, here we go, the farmer is on the left bank. Remember this, the farmer is on the left bank at the end of S1. And at the start of S2, the farmer is on the right bank. So S2 must get the farmer, so at the start of S3, the farmer is on the right bank. So S2 must get the farmer across from the left bank to the right bank. And that means you'll either have to make one trip, or you'll have to make 1, 2, 3 trips, or you'll have to make 1, 2, 3, 4, 5 trips. You'll have to be an odd number of trips. If the farmer only makes even trips, he ends up on the same bank as when he started. So at the start of S2, the farmer is on the left bank, right at the end he's on the right bank. Okay, so that's the first thing. S2 must have an odd number of steps. And now we can guess that it's 3 steps exactly. Or if that doesn't work, we can't find a solution, we have to guess 5 steps, or 7 steps, or 9 steps, but it'll be an odd number. An odd number. Right. So we're starting from this position, goats on the far side, we do something where we get somewhere, and then we can reverse those things right at the end. So that's fine. We only have to kind of like do half because the rest is a mirror image. If the solution is to remain symmetric, right in the middle, if this whole solution is symmetric, perfectly symmetric, then you can turn all the actions around, all the states around, then the right in the middle, the state must be the following. B, F, A, B. So there's a wolf and a cabbage, or a cabbage and a wolf on each of the banks. The farmer is right in the middle of the goat. That's only symmetric action. That's only action where I can swap it around and it stays exactly the same. So somehow I'm cheating because I'm saying that I want a symmetric solution. It makes sense that I do. So I know that the very middle action must be that B, F, A, and B. And if that's a middle action, I can calculate that On this side, the farmer must have been on the right bank, and now he's coming back from the whatever. So, sorry, the farmer, the goat, and a bee must be on the right bank. He comes back, and then he comes to the left bank. So by knowing what this middle action must be, I can somehow deduce this first starting and ending action. And now all I have left to do is to see, can I get from this state, F to BA, to this state, B, FAB. Can I do one action to get from here to here? And if I can, I've solved the whole thing. If I can't, I'll probably need 2 steps here and 2 steps here, or 4 steps here and 4 steps here, or 3 and 3 even. Okay. Luckily, I can do exactly what I promised. So I can go from this very initial state, where only the goat is on the far side. When I take over, let's say, a wolf, now I'm in B, fab, B fab, symmetric action, fab, B, and then I just reverse everything. Okay, and so now I have S1, S2, and S3, and altogether they're like S0, which is the real solution, the final solution. Okay, I've got like 6 minutes, so let's just look at a few other examples of these kinds of problems. 3 couples wish to cross a river. I promise you'll see millions of these if you start looking. Tons of reactions. This one is almost identical, but slightly different. 3 couples that want to cross a river. I don't know why people always want to cross a river. They have one boat that can carry at most 2 people. Making several trips necessary. Okay, that's fine, Danny. The wives are nervous of the other wives' husbands. What do you know? Okay. The wives don't be alone with someone else's husband unless their own husband is also present. Oh. How can all 3 couples get across? Now, this is not exactly the same as the wolf cabbage goat problem. A little bit trickier, but it's basically the same thing. You find some kind of notation, you work out how you want the problem to go, and most of all, you use decomposition to break it into smaller parts to get to smaller solutions. Okay, here's another example, which is very different. Here you need to add some mathematics, some numbers to the whole thing, but it's roughly the same genre. So 4 people want to cross a bridge, it's dark, they have to use the torch, but they only have 1 torch between them. The bridge is narrow, only 2 people can be on it at any time. I don't know where these people live, where they have small boats and clumsy bridges, never mind that. So there can only be 2 people on the bridge, and they want the torch. They also need the torch. Why do they need the torch? It's to prevent the first 2 going across, and then the next 2 going across as well. And that would be a pretty simple solution, and it would not be a very fucking puzzle. So they're putting the torch, which is really a different word for boat. Okay? Torch is like a boat. You can only go one side. You have to take multiple trips. Okay, bridge is now only 2 people. The 4 people take different amounts of time to cross the bridge. My God, what is wrong with these people? The slowest, the fast person, the fastest takes 1 minute. Must be quite a long bridge. Second takes 2 minutes, 5 minutes, and 10 minutes. And now the question is, please show that you can take all people across in 17 minutes. Let's just think of a simple solution. Let's use the 1 minute guy as a courier. First he goes across with the 2 minute guy, comes back, then he goes across with the 5 minute guy and comes back, and then he goes across with the 10 minute guy and comes back. 2 plus 5 plus 10 is 17. Oh, but the 1 minute guy has to come back twice. So that's 2 more 1 minute trips, that's 19. Wow. Doesn't quite work. Do I have more examples? No, those are my only 2 examples. In tomorrow's start, we'll be doing this kind of thing. I'll give you a problem, and I'll ask you to solve it with introduction and or event and or even decomposition. Okay. Remember to come to the right group. If you're not in the right group, I'll kick you out. I'll have to kick you out. Thanks, guys.